Here are the two tests that I can come up with. So one example is where you have an island. Yeah, it's one example, an island. Again, just for the purpose of these tests, both lateral boundaries are closed here on the left and on the right. You can see this is closed. And you create a wave by having a tsunami. You prescribe an elevated sea level in an area here on the left side of the model, and then you get the propagation of this signal. So now it all depends on how do you treat this transition between wet and dry grid cells. If you specify that the horizontal velocity always has to be 0, then it's closed, okay? And the water will never make it over the island. But I use the flooding algorithm, and it's your choice, okay? And if you use a flooding algorithm, what you want to see is that the tsunami actually makes it over the island. The second, even more extreme example is actually one where you have water on a hillside. So it's actually everything is land except for a little blob of water that you start here on the top of a hillside, which also has a depression. There's a little hole in here. This is scenario 2, and let's have a look at it. Let's have a look at the first scenario. I started. This is a snapshot, but the simulation I show you on the next slide. So how does it work here? You see side views and you only see the tip of the island, and you can see the sea level elevation. The top left here is after 40 seconds, and then the top right is after 60 seconds. Then the left and the middle is after 80 seconds, and then you get 100 seconds, 120 and 140 seconds. And you can see, if you follow these, you can see that there's a wave coming from the left, a tsunami wave, moving over this island and propagating also on the right hand side. This is only possible with the implementation of a flooding algorithm. This is how it looks like. You get your tsunami, it flops over and moves over to the right, becomes reflected, moves back, and actually makes it even back from the right hand side again. A little comes over to the. Okay, this is one example of the flooding mechanism. And here you can also see the tendency to develop these standing waves and closed basins, which are these type of oscillations go up and down. These are created through the reflection at solid boundary. Okay, so this was scenario 1, a test of the flooding algorithm.